Now let's talk about vector. I think you have studied about vector throughout your first year syllabus. You have studied everywhere in every chapter. Vector you have used. And you know many things about vector. I think everything is known to you. So just we will revise some of the basic results of vector. So just see here, I am not going to tell you vector will have direction, vector will have magnitude, what is null vector, what is unit vector, all these things are known to you. You have used these things throughout your chapter. So just here what will be the basic things I will talk about. So okay, so this is what we have here. Or one thing also I can say, you can write every vector A as A magnitude into A direction. This is known as unit vector. This is known as magnitude of vector. This is vector. So you can find unit vector also. Unit vector will be given vector by its magnitude. And what is magnitude of unit vector? 1. That is again an important question. So they may give you tomorrow vector 2i cap plus 3j cap plus 4k cap, and they will ask you find the unit vector. So vector divided by its magnitude. I think everyone knows how to find the magnitude of vector under root of 2 square plus 3 square plus 4 square. That is coefficient of I cap, j cap and k cap. So every vector will be written as magnitude into direction. Direction will be vector by its magnitude. Magnitude you can find. I think everyone knows how to find the magnitude. Now if we have two vectors and someone asked me to add those two vectors. So for adding we have triangle law, we have parallelogram law, or if more than two vectors are there, we will use polygon law. So just see the basic result which is used everywhere in physics, and I know all of you have also used all these results. So just see those results. So first result is for resulted. So always remember this we have added with the help of triangle law of vector addition. So you must know for applying triangle law of vector addition, head of one vector must be present at tail of another vector. You can see, you cannot use like this. Someone for example give you two vectors like this, A vector and B vector. So don't think this will be your resultant, it will become wrong. For using triangle law of vector addition, head of one vector must be present at tail of another vector. So I think you know, if anyone asks you to use triangle law of vector addition, you know about parallel shifting of the vector. You can shift this vector from here to here, and then you can find the resultant. So that is the process, and magnitude of resultant will come, I think everyone knows, under root of a square plus b square plus 2ab cos theta. If subtraction is there, minus will come, a square plus b square minus 2ab cos theta. Then if a and b both are equal, then resultant will come, r will come 2a cos theta by 2. On addition, on subtraction, r will come 2a sin theta by 2. Then range of resultant. Resultant will have minimum value a minus b. Resultant will have maximum value a plus b. Again important part, question has been asked from here. For example, they will say you two vectors having magnitude 3 and 4, 3 and 5, for example 3 and 5 are added. Two vectors have magnitude 3 and 5. Which of the following cannot be possible resultant? So 3 and 5 means maximum value will be 8, minimum value will be 5 minus 3, 2, larger minus smaller. So all the values between 2 to 8 will be its range, it will lie in that range. Less than 2 not possible, more than 8 not possible. So these questions are asked. Now you know this is a theoretical point, I think everyone knows minimum coplanar vectors needed for 0 resultant will be 3. Minimum non-coplanar vectors needed for 0 resultant will be 4. And you can find angle also. Always remember this theta which you have got here is the angle between the two vectors, and angle will be always angle, this angle you have to take. Don't take this as your angle, it will become wrong. You know, angle must be angle between head of the vector or tail of the vector. And you can also find the angle made by resultant with a given vector. For example, if given vector is a vector, someone asked angle, you know this result, r will be equal to b sin theta upon a plus b cos theta. Now one question is asked, they will give you diagram like this and they will say you, if vector a has more magnitude, then out of alpha and beta, you can see resultant is making alpha angle with a vector, beta angle with b vector. So question is asked, if a is more, if magnitude of a is more, then out of alpha and beta who will be more? So student thinks that if A is more alpha, no. You have to use basic concept of triangle which you studied in class 9, 10th. Angle opposite to larger side will be always larger. If A has more magnitude, means this side length will be more. If this side length will be more, angle opposite to it, beta will be more, which you can see here. A is more than B. So don't think angle with alpha A will be more. No. If A is more, then angle opposite to A will be more. So who is that angle opposite to A? That is beta. Beta will be more than alpha. Similarly, someone says B is more. So don't think that angle with B, beta will be, no. Angle opposite to larger. So angle opposite to beta, B vector is alpha. So alpha will be, both are equal, alpha and beta will be also equal. Now resolution of vector, easy part. You have done so many things. A vector angle theta, so two components will come, A cos theta, A sin theta. A sin theta is perpendicular component, A cos theta is parallel component. These are, since these components are perpendicular, that's why they are known as rectangular component. So magnitude of a vector you can always write as A under root of these two component square, parallel square plus perpendicular square. For example, if you have force F, it will have two component fx, fy. So what is your f net? Under root of fx square plus fy square. Now one more thing which is not written there. Always remember, when you rotate a vector, rectangular, if you rotate a vector, theta will change. If I have a vector like this, if you rotate this vector, angle will change. So rectangular components will change, but magnitude is not going to change. You tell me, if I start rotating this marker tomorrow, you can think angle with a given line, given axis will change. But does length of marker is changing? No. So always remember, whenever a vector is rotated, its rectangular components changes. But one thing do not change, its magnitude. And questions are asked related from here. So these are the basic things associated with addition of two vectors. Now let's start with one more important part. Now we'll be talking about relative velocity. Again, in relative velocity, I think all of you know, velocity of an object with respect to another object is known as relative velocity. So again, we will get three velocities here. One will be, two objects will be there, A and B. So they will have velocity VA and VB. And out of them, one will be observer, other will be object. So this is how we relate. So again, we will get three velocities, VA, VB and VAB. So velocity of A, actual velocity of A, actual velocity of B, this is relative velocity. And we say VAB means velocity of A with respect to B. VBA, velocity of B with respect to A. So here who is observer? B is observer. Who is observer here? A is observer. And always remember, observer always treat himself at rest, and he gives his velocity in opposite direction to the object. So actually what is VAB? VAB is VA minus VB. Actually it is not VA minus VB, it is VA plus of minus VB. Because B is observer, so B is giving his velocity in opposite direction to A. You know, observer, if you talk velocity of A with respect to B, that means B is observer. And in physics, always observer always treat himself at rest. He will be at rest and he will give his velocity in opposite direction to the object. So that is what we got. VAB, B is observer, so B gave his velocity in opposite direction, that is minus VB. VBA, his observer is A, so A is giving his velocity to be in opposite direction. If the object moves in opposite direction, I think everyone knows, relative velocity will become V1 plus V2. If objects move in the same direction, relative velocity will become V1 minus V2. Larger minus smaller questions are asked from here. They will say you two trains having same length going in opposite direction. Find the time to cross. So for time you need length and speed. So length will come L1 plus L2. If they are going in opposite direction, relative speed will become V1 plus V2. If they are going in same direction, relative speed will become V1 minus V2. So L1 plus L2, that is the total distance for crossing upon speed. And a time will be distance by speed. What is the distance for crossing of the train? This plus this, that is L1 plus L2. upon, if they are going in opposite direction, v1 plus v2, if they are going in same direction, v1 minus v2. Now let's see one simple question based on this form of relative velocity which we studied right now. This is also a famous type of question. They are saying you there is a cyclist who is riding in the east direction with a speed of 10 meter per second, and wind is blowing, here wind is there, and wind is blowing from south with a speed of 10 meter per second. Find the speed and direction of wind observed by the man. So you can say very easily, you will be saying, sir, you are asking us relative velocity. Means whose relative velocity you are asking? You see, find the speed and direction of wind. That means we have to find relative velocity of wind with respect to man. And we know relative velocity of wind with respect to man will be Vw minus Vm. Now wind velocity you can find, actual velocity of wind you can find, because it is given, and wind is blowing from south. From south means what is direction? From south means it is going towards north. So velocity of wind you can write. Don't write 10 minus 10, no. These are in vector form. So you have to write in vector form. So wind is blowing from south. From south means it is going to north. So wind velocity will become 10 j cap. Man velocity directly given. Velocity of man is given as 10 meter per second towards east, to 10 I cap. Now you can put here and you can get. So velocity of wind with respect to man you can put here. This will be 10 j cap minus 10 I cap. So if anyone asks you magnitude of this velocity will come, speed will come 10 root 2 under root of 10 square plus 10 square, that will come 10 root 2. Anyone asks you direction you can find. If you see, j cap means north direction, I cap means opposite to east, that is west direction. So what is the direction observed? Direction observed will be, you can see, northwest. So this is how we can talk about simple questions based on relative velocity. Now let's talk about one more important part, one more type of question which we have in motion in a plane. We are going to talk about rain man problem or rain umbrella problem. So easy questions are asked from here in your NEET exam. So just see here how to do the question. What will happen in rain umbrella problem? What will happen in rain man problem? So let's see. First we'll talk about basic thing. So always remember, in rain umbrella problem, rain man problem, 3 velocities you have to deal at the same time. One will be the actual velocity of rain. Obviously rain will be falling with some velocity, maybe vertical, maybe at some angle. So first 3 velocity in rain man problem, 3 velocities you have to deal. One will be the actual velocity of rain, one will be the actual velocity of man, and one will be the velocity of rain observed by the running man. This is the relative velocity, velocity of rain with respect to man. So in rain umbrella problem, rain man problem, 3 velocities will come. One will be the actual velocity, obviously rain man problem, so one velocity with which rain will come, sir, one velocity with which man will run, and one velocity of rain observed by the man. So you have to always relate these 3 velocities. If you are able to relate, you will get answer in every situation. Now what is said in the question, how you will relate? You know how to find relative velocity. That is velocity of rain with respect to man, relative velocity. You know VAB will be VA vector minus VB vector. In the same manner, VRM, velocity of rain with respect to man. So VAB is VA vector minus VB vector. In the same manner, VRM will be VR vector minus VM vector. Always remember. So this is the relation that you have to do. VRM, velocity of rain with respect to man, will be VR minus VM. Now always remember, if man will change his speed, man has control over his speed. If man will change his speed, the velocity of rain observed by him will also change. But one thing is not going to change throughout your rain man problem. That is rain velocity. Rain velocity, actual velocity of rain cannot be affected by Man will change his velocity. Velocity of rain observed by him changes, but actual velocity of rain remains constant in a given situation. Now just see one question based on what we have done right now. And this type of simple question, if it is asked in NEET, simple question will be asked from your rain umbrella problem, because already students feel this thing to be little tough, but we can do very easily. You have to read the question carefully, you'll get the idea. Just see here what is said in the question. They're saying you a man running with a speed of 4 meters per second, means the velocity of man is given. Just see how easy. So velocity of man is given. What is velocity of man? You can assume man running in any direction. You can assume man running towards east. Take east direction, horizontal direction as your x-axis, vertical direction as your y-axis. So we'll be saying, it is said, a man running with a speed of 4 meters per second, that means man velocity is known, sir, 4 I cap. We have assumed horizontal direction to be x-axis. So velocity of man will be 4 I cap. Running towards east, running in horizontal I have taken as I cap. Finds that a man running with a, you have to read question carefully. A man running with a speed of 4 meters per second finds that raindrops are hitting him vertically. You can see velocity of rain is given 3 meters per second. You tell me which velocity is this? Is it actual velocity? No. Finds, running man finds that. That means velocity of rain is given, sir, but this is not actual velocity. This is velocity of rain with respect to man. VRM, that is given as vertically downward. Running man finds this. So VRM, vertically downward, means minus 3 J cap. Now actual velocity and direction they are asking you. So now you can do, you know, sir, VRM is known, VM is known, we can find VR because we know relation. VRM will be equal to, sir, VR vector minus VM vector. Just you have to do this. What is VRM? VRM is, sir, minus 3 J cap. This will be equal to VR vector, we don't know, VR minus VM. What is VM vector? 4 I cap. If you send this side, you'll get VR. You'll get VR vector as, this will come this side, so it will become 4 I cap minus 3 J cap. You can send this side, so it will become plus. So 4 I cap minus 3 J cap. If anyone asks you speed means magnitude, you can get very easily magnitude under root of 4 square plus 3 square, that will give you 5 meters per second. This is the actual speed of the rain. Now, sir, how to get direction? And in direction, students start feeling problem. So just see the method how to get the direction, how to write that direction. Just see. So for direction, you will do like this. What you will do, you will say, this is the process you have to follow for direction. You will say, sir, this was our horizontal direction, this was our vertical direction. If you look at the rain, sir, if you look at the actual velocity of rain has two components. You can see along positive x-axis, how much? 4. Positive x-axis 4, negative y-axis 3, minus 3 J cap. So this is net resulted, sir, net resulted. Now you know rain will come from top. It's not like that rain will start from here. You are here. So in order to protect yourself, you will keep umbrella like this. This is how you will keep your umbrella. They will ask you find angle with the vertical, this theta, same theta is this. This is how you will keep the umbrella. Rain is going like this. You are not going to collect the rain. You are going to protect yourself from rain. You keep umbrella like this. So they will ask you from vertical how much angle. So from vertical you can find the angle. If this is, they are asking you from vertical, you can do vertical, horizontal, you can do horizontal. Here I am asking with vertical, theta. So this is theta. So you can write tan theta will be equal to perpendicular by base 4 by 3. That means theta will be 53 degree from vertical. 53 degree from vertical in backward direction. 53 degree from vertical in backward direction, or 53 degree from vertical in anti-clockwise direction. Or if your person is running in east, so 53 degree from vertical towards west, you can see backward will be west. So this is how we can solve simple question based on rain man problem. we are going to start with river boat problem, or you can say river swimmer problem also. And again, this is important part. Last year only in NEET one question was asked, and that question asked was very easy. So easy questions are asked, simple questions are asked based on basic understanding. So we'll start with river boat problem, or you can simply say river swimmer problem also. So I think everyone has done this type of situation. So just we will revise what happens in river boat problem, what happens in river swimmer problem, and what are the important results there. So just see here how we'll be talking about. So in river boat problem or river swimmer problem, what will happen? You will find that one river will be there, and that river will be flowing, and there will be one swimmer present on one bank of the river, one side of the river, and this swimmer will try to cross the river. Now there will be various conditions for swimmer to cross the river. One condition may be swimmer has to reach exactly opposite point. One condition, swimmer has to cross the river in minimum possible time. So we'll be studying what will be conditions for these situations. So understand. So see here. So as you can see in the diagram also, there is a river which is flowing with speed VR. There is a swimmer who is waiting on one side of the river, and speed of the swimmer is Vs. That is speed of the swimmer with respect to still water. Means if water is not flowing, then in that situation speed of the swimmer will be Vs. But you know, once your swimmer will enter in the river, due to river its speed will be affected. Due to river its swimming will be affected. So we have to consider all those situations. So first important case comes. Swimmer is waiting at A. He wants to cross the river. So first thing we will say to the swimmer, you cross the river to reach exactly opposite point. Your swimmer has first condition. Swimmer has to reach exactly opposite point. So tell me, if your swimmer will try to reach exactly opposite point, if swimmer starts swimming like this, it will be not possible for swimmer to reach exactly opposite point because river is there. River will drift himself. So if swimmer wants to reach exactly opposite point, he has to balance the river flow. And that's why your swimmer will start at some angle theta. And when swimmer will start with some angle theta, you will find that one component of swimmer, you can say if this is Vs, this is theta, this component will come Vs sin theta. If swimmer has to reach exactly opposite point, he has to balance the river flow. How your swimmer can balance the river flow? By giving one component of his velocity opposite to the river. You see, if his swimmer starts like this, he will never reach there. Due to river, he will drift. So we are saying, sir, but swimmer has to reach exactly opposite point. That means one component of his velocity must balance the river flow. And that is what you have got. Reaching exactly opposite point B, and that is also your shortest possible path to go to on other side. That is your shortest possible path. For that, one component of swimmer velocity Vs sin theta must balance Vr. So from here we get condition for reaching exactly opposite point, that is sin theta, theta with which your swimmer will start. This theta must be equal to Vr by Vs. Important result. And question asked this last year in NEET exam was solved by this formula only. So swimmer, one component of swimmer velocity must balance river flow, then only your swimmer will be able to reach exactly opposite point B. Now I will be saying, sir, in how much time he will cross? Okay, sir, he will go on shortest path, he will reach to exactly opposite point, but how much time he will take? If you see, one component of swimmer velocity will be saying, sir, Vs sin theta went in balancing the river flow, but one component is there which is Vs cos theta. Due to Vs cos theta, your swimmer will cross. So how much distance he will cross? W. With how much speed? Vs cos theta. So what is time taken? W upon Vs cos theta. You can see the distance he will cross upon the speed with he will cross. Because his Vs sin theta is already gone in balancing the river. He wants to go exactly opposite point. That means he has to balance the river flow. So from there we got Vs sin theta equal to Vr. Sin theta will be Vr by Vs. Someone asked in how much time he will cross. So for time you can say velocity remaining for crossing is Vs cos theta. Distance W. So time will come W upon Vs cos theta. Now you have to be careful about this theta. If anyone asks you find angle perpendicular to the river flow, with which he will start, that is theta. If anyone asks you find angle with the flow, so angle will become 90 plus theta, or against the flow 90 minus theta. So you have to see in question they are asking angle with which quantity. Okay, so swimmer is there, understand, swimmer has to reach exactly opposite point. He will starts like this, he will never reach, he will drift. So he has to balance the river. Why he is drifting? He is drifting due to river. So if you want to reach exactly opposite point, he will start like this. So that one component of his velocity, Vs sin theta, will balance river. And another remaining component, Vs cos theta, will let him cross the river. So time taken will become W upon Vs cos theta. And angle theta is with the perpendicular to the flow. If anyone says you find angle with the river flow, 90 plus theta, against the river flow, 90 minus theta. Okay, no problem. Now, second situation, our swimmer has to cross the river in minimum possible time. Minimum possible. Where he will go doesn't matter to us. Sir, he will reach here, he reach here, he reach here, doesn't matter to us. We want swimmer to cross the river in minimum possible time. So, we'll be saying, sir, for minimum possible time, cos theta should be maximum. You can see here, time is inversely proportional to cos theta. So, for time minimum, cos theta maximum. Maximum cos theta will be 1 when theta will be 0. So, T minimum will become, if you put maximum value of cos theta 1, so T minimum will become W upon Vs. This is the minimum time in which this is also known as quickest path. But you tell me, does your swimmer will reach here? No. He is crossing the in minimum possible time, but due to, and how he will start? He will start like this. You can see theta will be 0, means he will start perpendicular to the flow. When he will start perpendicular to the flow, due to river, he will drift. He will go here, somewhere here. So we can calculate that drift also. Who will drift him? River. With how much speed? Vr. And for how much time? W by Vs. So drift will come Vr into W by, means speed of drift into time. That will give you distance. So this is also known as quickest path. If swimmer has to cross the river in minimum possible time, he will give whole of its velocity in crossing the river. Whole Vs will come in the whole Vs will come for crossing the river. So how much time will become? W by Vs. But during that time, due to river, he will drift. How much distance he will drift? So speed of drift will be Vr into time W by Vs. So that is the drift you got. Sometimes we can get general situation also. For example, someone says, sir, if Vs sin theta becomes more than Vr, if Vs sin theta becomes more than Vr, that means our swimmer will move to left side. If Vs sin theta becomes less than Vr, our swimmer will go on the right side. So you can find drift also, and velocity responsible for crossing will be Vs cos theta only, because your crossing will be done across this line. So we can find in general situation also. So if I say, sir, Vs sin theta is more than Vr, so you'll get net velocity of swimmer in this direction. So swimmer will reach somewhere here. Someone will ask you find this distance. So you can find net velocity in this direction. Vs sin theta minus Vr into time. That will be your distance. Time will be W upon Vs cos theta. Similarly, you tell me if I say Vs sin theta is less than Vr, that means Vs sin theta is less, Vr is more. So your swimmer will get net velocity in this direction. How much remaining, Baba? Vr minus Vs sin theta. Due to that, he will drift in that direction. For how much time? W upon Vs. So you can write this. Now for that, you can write Vr minus Vs sin theta into time, W upon Vs cos theta. That will be your drift. So this is what we have got in river swimmer problem. Again, I will tell you, a river is there, swimmer is there, swimmer wants to cross the river. So first situation, shortest path. Shortest path means reaching exactly opposite point. For that, swimmer component of one velocity Vs sin theta must balance Vr. So Vs sin theta will be Vr, so sin theta will be Vr by Vs. This is the condition, theta from the perpendicular. Time taken will be W upon Vs cos theta. Someone is saying, sir, swimmer has to cross the river in quickest path. Quickest path means minimum possible time. So for that, cos theta should be 1. So minimum time will become W upon Vs. But during that time, due to river, he will drift. How much speed he will drift? VR into how much time? W upon Vs. So that is the drift in that situation. And third situation is a general situation which we can use. Now let's see one question based on river swimmer problem which we just studied. So just see here, just to give you idea, just to revise, I am talking about one question. Easy question but important type of situation. So just see here. If you read the question, you will find that they are saying you, there is a swimmer. A swimmer can swim with a speed of 5 meter per second in still water. Okay, speed of swimmer is given 5 meter per second. River is flowing. VR is also given, river speed is also given, river is flowing with a speed of 3 meter per second. Width of the river is given as 100 meter. They are asking you, all the possible questions are there. Find. First situation, they are asking you angle with the flow with which he will start to reach exactly opposite point, means shortest path, and time for shortest path. So you have to find in this time for this situation. Then they are asking you what will be the time for quickest path. Quickest path also means minimum possible time. So you have to find minimum possible time. Next one, drift for quickest path. So you have to find drift for this. So all those 4 results that we studied just now, all those 4 results will be used here. So just to revise, just to see how to apply those results, I have taken this situation. So just see here, how I will solve. Just see. First question they are asking you, angle with flow with which swimmer starts. I know, sir, if swimmer has to reach exactly opposite point, he has to balance the river flow. And for that we know, sir, for that we will get, sir, for that Vs sin theta must be equal to Vr. One component of swimmer velocity will balance river velocity, then only he will reach exactly opposite point. So that's why Vs sin theta will be equal to Vr. From here you will get sin theta as Vr is 3, Vs is 5. So if you put here, you will get sin theta as 3 by 5, that means theta will be 37 degree. But don't think that answer is 37 degree. No, this is what I said you just now. Theta you have to see with what they have asked the angle. They have asked the angle with the river flow. With the perpendicular, theta is 37. With the river flow, the angle which will be here, which will be our answer, will be not theta. They have asked you theta with the river flow. So angle with the river flow will become 90 plus 37. That is 90 plus 37. So your answer will be 127 degree. So this is how we can talk about. Now they have asked you in second situation, they have asked you time for shortest path. So they are asking you time for this situation. So you know time will be coming as, so time will come W by Vs cos theta. Just now we studied, so W is given as 100, Vs cos theta, so Vs is 5, cos theta, cos 37 is 4 by 5, so this will come 25 second. Or you can think like this also directly. Sir, swimmer has total velocity 5, out of which 3 he will give to balance the river. This is how you can minimize your time. So swimmer has total velocity 5, out of which 3 he gave to balance the river for reaching exactly opposite point. 3 he gave to balance. So how much remaining? 4. So how much time he will take? 100 by 4, 25. Directly you can do like that also. Now next situation, they are asking you time for quickest path. You know, for quickest path, swimmer will give whole of his velocity for crossing the river. So time, minimum possible time will come W by Vs. What is W? 100. And what is Vs? Vs is 5. So from here you can get this as 20 second. Now they have asked you drift for the quickest path. You know, in this situation swimmer will not reach exactly opposite point, he will drift. So we'll make him drift. River will make him drift with how much speed? So you know time drift will be coming as Vr into time. So Vr, who will drift him? River. So with how much speed? 3. For how much time? 20 second. So it will be coming as 60 meter. Or you can use formula also, Vr into W by Vs. So same value will come. So this is how we have talked about situation. Now one more type of question is asked here, which students feel little problem. They will say you, a swimmer can save, if you see your swimmer can save 5 seconds by going on quickest path instead of going on shortest path. So they can ask you like this, while going on quickest path, a swimmer can save 5 seconds for what he took in shortest path. And they may ask you find width of the river. So this time gap you have to calculate and you have to subtract, you will get answer from there. So this is how we can talk. With one more part, we'll revise with circular motion. And here we will talk only important terms associated with circular motion. We will not talk about forces which are responsible for circular motion. We will only talk about kinematics of circular motion. Dynamics we study in another part. So we'll talk about kinematics of circular motion. So as you can see here, some basic formula are there, basic results are there, and these results are used to solve questions in circular motion. And many times question in the NEET are asked from these results directly. So just revise these results. So see here. First thing, distance they will ask you. I think everyone knows distance will be the length of arc. Particle will move on circular path. So whatever the length of arc he will move, that will be your distance. So L will be equal to theta into r. I think everyone knows theta will be L by r. So L will be theta into r. Theta must be in radian. Second, displacement. If the particle will move, it will sustain an angle theta at the center. So displacement, direct formula which is known to everyone. Displacement of the particle will come 2r sine theta by 2. Again an important result. For example, they will say you tomorrow if the particle moves such that angle subtended at the center is found to be 60 degree. Radius is 10 meter. Find the displacement. So displacement you can directly put 2r sine theta by 2. If distance is asked, L will be theta into r. Now you know in this circular motion we talk about velocity, we talk about displacement, we talk about acceleration. But apart from these three, we talk about three angular quantities also. Angular position, or you can say angular displacement, angular velocity, angular acceleration. So basic result, angular velocity will be d theta by dt. Same as your velocity ds by dt, angular velocity will be d theta by dt. Alpha, angular acceleration will be d omega by dt. V vector, your linear velocity, or you can say this velocity will be tangential. You know in circular path, velocity will be in tangential direction. So V vector will be equal to omega cross r. At will be your alpha cross r. Same thing. These are angular quantities, these are linear quantities which we are relating. So omega will be d theta by dt, alpha will be d omega by dt, V will be omega cross r, At will be alpha cross r. Now you know on circular path your particle may have two acceleration. I think everyone knows on circular path your velocity can change due to two factors. Obviously velocity is vector quantity, so it will change due to two factors, one due to change in magnitude, one due to change in direction. So we have two accelerations here. One acceleration will be responsible only for change in direction, and that is your AC. Always remember, on circular path particle may have two acceleration. One acceleration which is responsible only for change in direction, that is your centripetal acceleration. So you tell me what centripetal acceleration do on circular path. Centripetal acceleration will change the direction of velocity. So AC responsible only for change in direction. Its value will be V square by r, or you can write omega square r. Another acceleration will be responsible for change in magnitude of velocity. Magnitude of velocity means change in speed. That is your tangential acceleration At. So At will be responsible only for change in magnitude. So At will be also equal to rate of change of speed. It is changing the magnitude, or that will be also equal to dV by dt. That is, we are differentiating speed. Rate of change of speed means differentiation dV by dt, or we can say V dV by ds, or that will be also equal to alpha into r. So always remember, on circular path your velocity can change due to two factors. Due to change in direction, who is responsible for change in direction? Centripetal acceleration, AC, VA square by R or omega square R. Or one acceleration will be responsible for change in magnitude. What is that acceleration? Change in magnitude, change in speed. That is tangential acceleration AT. Or dv by dt or v dv by ds, or you can say alpha into r. Always remember, this will be always present in circular motion, because for going on circular path, direction must change. Speed may change or may not change. Magnitude may or may not change. So AT may or may not be present, but AC will be always present. You cannot have a circular path without AC, because if you are going on circle, your direction must change, and for changing direction, one acceleration must be present, and that acceleration is your centripetal acceleration. This may be there, may not be there. Now, so net acceleration, as you can see here also, one acceleration will be responsible for change in direction, that is centripetal acceleration. One responsible for change in magnitude, that is tangential acceleration. So net acceleration will come under root of AC square plus ATA square, which you can see here. And you can find alpha also, tan alpha, perpendicular by base, that is AT by AC. And you can use equation of motion here also, same three equation, V equal to U plus AT. So here omega equal to omega naught plus alpha t, there S equal to UT plus half AT square, here omega theta equal to omega. So you can use same equations here. Okay, no problem. Now, as you know, we have two types of circular motion. One will be uniform circular motion, one will be non-uniform. Uniform means speed will be constant. You cannot have circular motion where velocity will be never possible, because you know on circular path direction will always change. Magnitude may change, may not change, but direction will always change. So always remember, so we cannot have a circular motion where velocity will be constant. Velocity will always change. But we can have a circular motion where speed will be constant. Sir, body is moving in circle, but speed is constant. I am not changing the magnitude. So in that situation, that circular motion for which speed remain constant is known as uniform circular. It is not example of uniform motion. Always remember, question has been asked in NEET. Does uniform circular motion is example of uniform motion? No. For uniform motion, velocity will be constant. You tell me here, does velocity will be constant? No. Always direction will change. So always remember, uniform circular motion means it's not example of uniform motion. Second thing, velocity will never be constant, but speed will be constant. So in a circular path, if your speed is constant, it will be known as uniform circular motion. So speed constant, but velocity will not be constant. But omega vector will be constant. Omega vector will be constant because its magnitude, since V magnitude is constant, so omega magnitude will be constant. And its direction will remain constant because it will be always perpendicular to the plane. So that's why omega vector will be constant. Magnitude of AC will be constant. V, you know, AC will be V square by R. V value will not change. So obviously AC magnitude will not change. But in uniform circular motion also, direction of AC will change. Because for example, right now particle is here, so AC will be like this. When particle will come here, AC will be like this. So direction of AC will change. That's why AC vector will change, but magnitude will not change in uniform circular motion. But if you talk about in all these situations, since your speed is constant, you know tangential acceleration is rate of change of speed, so tangential acceleration will be 0. Speed is constant, that means kinetic energy will be constant. Kinetic energy has nothing to do with direction. But momentum will not be constant, because you know momentum will depend on, momentum is vector. So it will depend on direction, so that's why momentum will not be constant. But angular momentum will be again constant, because angular momentum is I omega, omega vector is constant, so L vector will be constant. So this is what will uniform circular motion means. Don't think that it is example uniform motion. No. Uniform motion means velocity. You tell me, does it is possible to have a circular motion where velocity is constant? Impossible. Direction will always change. So when only direction changes, magnitude remains constant, we say uniform circular motion. Non-uniform, everything will change. So this is how we have got basic idea of kinematics of circular motion. Let's see some question based on circular motion which we studied just now. So some very famous type of question. Already this type of question has been asked in your NEET exam. So just see how to use the result that we studied right now. So if you look the first question, they are saying you a car starts moving on a circular path of radius 100 meter such that speed increases at a constant rate of 3 meter per second square. Find acceleration when its speed becomes 20 meter per second. Okay, so they are asking us acceleration. Always remember, if neither centripetal is mentioned, neither tangential is mentioned, that means they are talking about net acceleration. If nothing is mentioned, obviously you will calculate net acceleration. So they are asking you net acceleration. I will be saying, sir, for net acceleration, sir, I know A net will be under root of AC square plus AT square. Sir, AC I will get very easily because they have said find acceleration when speed becomes 20. AC I know, sir, V square by R. So 20 square by R is 100, this will come 4. Can you tell me how to get AT? How will find AT? Does anywhere they have said tangential acceleration? No. But if you see carefully, this is what you have to observe. They have said such that speed increases at a constant rate of 3 meter per second. What is AT? What I told you for AT? It is the rate at which speed changes, rate of change of speed, rate of change of magnitude. AT responsible for change in magnitude. That means speed increases at a rate of, that means this is the rate at which speed changes. Who changes speed? Tangential acceleration. That means AT is also given to you directly, 3. You can put here, you will get net under root of 4 square plus 3 square, that will give you 5 meter per second square. This previous year AIMS question, also important type of question. Now let's see one more question where we will use little differentiation. Just see, they have given you a particle moving on circular path whose speed is given as 2t, means speed is changing with time. Radius is given, they are asking you AC at t equal to 1. So we'll be saying we can find AC at t equal to 1 second you want. So we know AC will be, sir, V square by R. So at 1 second they are asking. So what is speed at 1 second? You can put here. So t equal to 1 second, your speed will be 2. So 2 square by R1. So that will give you 4. This is your AC at t equal to 1 second. V square by R. So you can find V at t equal to 1 second. You can use that. You will get AC. How you will get AT? Tell me. For that I told you AT will be dV by dt, rate of change of speed. If it is given in the terms of S, you will write AT as V dV by ds. If it is given in the terms of time, you write AT as dV by dt. Differentiate, put it, 2 will come. What is net acceleration? Under root of AC square plus AT square, that will come 16 plus 4 root 20, that is 2 root 5. Or they may ask you, find the time when AC will become equal to AT. So AT you know, AC you can find in the terms of time. You can equate them to find everything. They may ask you tomorrow find angle with the radius tan alpha, AT by AC. You can calculate all those things. So everything we can do with the help of just what the things we studied just now.